So first, shout outs to the community, and this is quite exciting because I feel like it's kind of picking up more steam. There are actually some more substantial contributions coming in now, and I'll get to those in a moment. First, some kind of first-time posts and interesting questions that came up this month. There were some interesting questions around motivation and what drives learning in Monty that Niels responded to a couple of times. Some nice insights and back and forth. There's some checking in on when the papers will finally be published. Then, yeah, someone from Brown University trying to get Monty up and running and trying to figure out some issues with the setup there that Tristan helped out on. DLED, if you remember, our very first external contributor, posting some anecdote about how you know how to hit a tennis ball correctly that he thought of when he watched our research meeting recordings about object behaviors. And then some good questions around like how the sensor modules work and the sensory processing works from node 0. Yeah, then people actually starting to use Monty or planning to use Monty. So there was an interesting thread here about Sergey who wants to use Monty in actually like a potentially commercial application. So he sent a whole PDF presentation about how it would be based on Thousand Brains theory and another framework kind of wrapped around it, and about like using a robot to quickly map out a warehouse environment and figuring out how to move in it without a whole bunch of training and avoid obstacles and moving objects. So that sounds really interesting. And then also here some more in-depth discussions on using Monty on the MNIST dataset and trying to improve speed and accuracy there. And then just generally looks like about 160 or 170 people almost forked our repository. Most of them have not commented or written us anything about what they're doing with it. So I have no idea if they are doing anything with it or just made a copy of it, but curious if anything comes out of any of those forks. And then, yeah, I had a couple of external PRs. So Anna made a nice PR, adding some instructions to our tutorials and fixing a couple of typos in there. Colin made a really nice PR. So he had written on our forum a couple of times before, and written with Tristan in particular also. And then submitted a PR about an alternative implementation of KD tree search, or finding the nearest neighbors, comparing CPU versus GPU implementation, and adding some nice analysis and everything, basically kind of showing how this could look. Eventually, it kind of turns out that what we have is currently actually the best solution. So didn't end up merging this PR, but it's been a really good example of a prototype and example of like showing code and experimenting and sharing results. So really appreciate it. Arnjun, I'm not sure how to pronounce it, but yeah, he submitted both an RFC and actual feature implementation. So the RFC outline is about generalizing voting to associative connections. And so essentially in our documentation, we have this future work section where we have our roadmap, and there are a bunch of tasks on the roadmap that anyone is welcome to pick up. And one of these tasks is this one, generalized voting to associative connections. If you look at kind of the subsections here, we also outline a bit of what we're thinking on that, on some of these items. But essentially, he outlined an RFC on like how this could be implemented, and then also opened a PR with an actual implementation already. And basically what this does is that right now, when we do voting, we kind of assume that each learning module has received the same label for this object. So like if we had two learning modules that saw the cup, kind of assume that they have received the cup label, and the graph has the same object ID representation, which is unrealistic. It's like assuming that each column uses the same SDR for an object to represent that object. And so we've had it on our roadmap for a while to make that more generalizable. So each learning module can have its own ID for an object. And then they just learn associative connections and can vote just based on co-occurrence of this object. And so that's kind of the idea behind this one. Then we also had
Can I ask a question about that? So how far did they get in that project?
Yeah, so there is a full implementation here, a couple of results as well, but we haven't gotten around to actually reviewing it yet. So it's been a pretty busy week last week with the paper release and everything. But the plan is that this week we actually like review it all and see like if there are major changes that need to be made.
I mean, it's a great project to do. I appreciate them doing it, and looking forward to see how. I mean, it's just a nice one to pick out of that big list. Right?
Yeah, and I mean, yeah, it definitely looks like, they've understood the problem really well. And so, yeah, as Vivian said, we haven't had a chance to look at the problem or like the implementation in detail, but imagine it fixes it. And I think it's just really exciting because this is the first time that someone's like specifically taken one of these future work kind of things where we've just suggested this could be an interesting thing to work on and specifically gone and implemented that. So yeah, definitely a great
I want to just shout out and thank them because you're right. It shows deep understanding of the issues. It is something that should be done, and but whether this pass works or not, I don't know. That's great. That was a nice choice, and that they're working on it. Thanks them.
Yeah, for sure. Definitely appreciate that contribution, and it looks like a well-structured PR as well, even adding some documentation around it and adding a tutorial for it in here. So yeah, looking forward to reviewing that and the RC. And then we also had someone write two really nice blog posts about Thousand Brains theory and Thousand Brains project. And yeah, I read both blog posts and I was really impressed by how well he understood all the concepts and how well he kind of explained them in simple terms and related them to some other ideas like Piaget's psychological studies and concepts. So that was really cool. We had a couple of people also on social media kind of tagging Thousand Brains project. So like, I'll recommend following Gary Marcus and Thousand Brains project here on a post that was about like how LLMs are still not good at like simple math stuff. Here, just some kind of comments on when I shared the blog post about how, we need to do sensory motor learning, and that's really important. And then also, this is something I'm really excited about or looking forward to. It looks like Artem Kirsanov, who does some really great neuroscience videos on YouTube. We actually have his channel in like our onboarding materials as a recommended viewing, because he explains like grid cells and things like that really well. And it looks like he's putting together a video about the microcircuit in a cortical column and said, it's about the Thousand Brains theory. So curious how that'll turn out and looking forward to it.
Yeah, I can't remember if we sent him a copy of the two preprints, but we probably that'll probably be worth doing because especially towards the end of his video, maybe.
Good idea, especially the hierarchy paper could be interesting as like a more up-to-date kind of extension of the theory. So that's a good idea. And then this is also really exciting. So now you've seen there were some more substantial contributions. So we actually have added 3 people on our roadmap now. I don't know if you remember, but we have this big kind of overview sheet. And so far, we've always had our team members on there, everyone with their icon that they picked when they joined. And I now added 3 people on here. Here's the generalized voting to associative connections. Then we have Colin, who worked on exploring fast saccade tree search implementation. I think that is actually checked off for now, since it turned out that the implementation we have right now is actually the fastest we can do for what we need. But as far as I know, he's still working on looking into other GPU accelerations of Monty. So I'll move him onto this one. And then we have Greg on publishing blog posts about Thousand Brains project or Thousand Brains theory. So yeah, really exciting, and kind of hope that this trend continues and we'll have more and more people on this roadmap.
It is really exciting, and I want to thank again those contributors. It's really cool to see that.
Yeah, definitely. Thank you to everyone who's been posting on the forum, and especially also contributing.
Okay, hi everybody. Welcome to Wednesday research meeting. Today we're going to be talking about morphological structure and in the context of everything else we've been working on. So don't have much in the way of slides, but I guess I'll just lay out the basic bullet points in PowerPoint.
So Scott, so did you put something together independent of what I was writing, right?
I basically just took your bullet points and put it on slides.
Okay.
That's
Okay.
it. So there's nothing, we don't need to do that. I
Right.
might as well just open the Word document.
Well, that's what I was thinking of doing. Yeah.
Do you want to open the Word document?
No, well, you can open the Word document. Or maybe I don't know, maybe I should, because then I can scroll through it easier.
Yeah.
But I don't mind starting with your bullet point slide. See what you thought.
Okay. Well, let's see how easy this is to. Yeah. At least I get to show this off again. Hey. Oh, come on. Oh well. That's too bad. Stay tuned for more Thousand Brains mugs and Monty. So these are the main line items, which we'll, get into. I started kind of trying to break them down a bit, but I think we're just kind of automatically sort of get into them. But morphological models themselves, just objects in the world have a shape. Deformations it can feel a little bit overloaded sometimes, talking about some deformations as variations of objects or deformations as behavioral, like in time deformations. But we can work out how to not confuse ourselves, I guess. Permanence, meaning like I'm thinking in 2 ways. It's things in the world can be temporarily or permanently sort of arranged the way they are, or they can be temporarily stored in memory versus permanently stored in memory. So 2 related but slightly different things. Objects that are composed or nested in some way, and then of course, as we've been talking about a lot, objects that change within their own reference frame, and spatial and temporal structure. Okay, so I don't need to take any more time reading bullet points. I'll throw this over to Jeff.
Yeah. So as I hinted in my or suggested in my Slack post, I just felt like our world is getting very complex in terms of our models, and sometimes it wasn't really clear what was going on. And then I would forget things and go back and go, oh no, we talked about this, blah, blah. So then I said, well, that's sometimes a good idea when things really get complex. Just go back, as we usually often do, and go try to review everything. And so I started thinking like, okay, we're asking this, a learning module, aka cortical column, to learn models of the world. And we've got a lot of different types of flavors of those models and the different types of. And so I started thinking about, there's all this kind of structure in the world. And I'll just try to enumerate or spell out the different types of structure that we know exist, that we know we can learn. And I thought that would be an exercise. And in the process of doing that, I was hoping that some clarity would come out of it. Like, oh yeah, these things are really the same, sort of a unified theory of structure and modeling. You know, like that science often does that. You start with a whole bunch of confusing things and then it solidifies and gets less confusing. So I can't say the exercise was successful in that, A, I didn't get through everything, and B, I was still confused as I was writing it up. But I do think it was useful. And I think it's useful to go through it as a team, to discuss it, and to people can propose, you know, if I've missed something, or, you know, you just already, Scott, you just point out like, oh, permanence can apply to both the permanence in the world or the permanence of the model. And I hadn't made that distinction. That was interesting and useful. I started out thinking along the lines of just thinking about the world. What are the structures in the world? So it wasn't a taxonomy of models, it was a taxonomy of structure. But it was hard to keep the two separate, because I don't know, it just was. I just kept sliding back and forth. So maybe we can just go through it item by item, just like you started to do, Scott, and then we can discuss them, and I'm sure just asking questions or proposing alternate ways of thinking about it would be a useful thing. So I think this is useful for me. I hope it would be useful for everyone. I don't want to take everyone's time, but I thought it would, even though I didn't complete the exercise, I thought it would still be worthwhile going through today. So is that okay? Does that make sense? Any questions?
I think what you wrote already sparked some discussion in at least, or like stuff to say in Excalibur. So yeah, let's do this.
Okay. Well, should I just share my screen and then look
That
at
sounds
this?
good.
Okay, I'll do that. Looking for the share down here. And I'm going to share, I'll just share that screen right there. I'm sharing a screen, it says, but it's showing me the wrong thing.
We can see your screen.
Oh, you can. Oh, I see. So I'm not seeing what you're seeing. Why is that?
It's just a bit zoomed out, so might be worth.
Word in full screen somewhere. It looks like it's full
well, I'm
screen.
using two. I'm got a split screen here, so let me just bring this back over here. Maybe that'll help. I want to see what you're seeing. Okay, that looks more like what I expect. So you're seeing my Word file here, right? And I'm scrolling up. Okay.
Yeah, and now it's more zoomed in. It looks good.
I'm okay. It looks good on my screen. It's a good size for everyone. Should I zoom in? Okay. The beginning of this document was this preamble of stuff we already know. And I don't know why I wrote it down again, just for completeness. Just sort of setting the stage here that, the whole idea of a brain or intelligent system is it's taking advantage of some kind of structured universe. And the whole goal is there are really two things, is to learn the structure of the universe or the world that it inhabits, and then build an internal model, and then use that model to act. I didn't spell it, but you recognize where you are, recognize your situation. You have models of how things typically behave, and it guides you into acting. So I didn't even talk about the acting at all here. I just said, okay, how do we build models of the world? That's the most important thing. When I think about like deep learning, I always think like, oh, what kind of model does it build? Or like the large language models, what kind of structure can it learn? And, it's a different type of structure. It's not the kind of structure we learn. It's a linear structure of tokens in some sense. But we, of course, learn the structure of the physical world by movement. So I talked a bit about sensory motor learning. We all know that now. And then I came up with this list of ideas. I started writing the easy ones. I started talking about composition, because we've already talked about that. And I said, no, let me go back and start with the hard ones, the ones that were most difficult, the ones we don't really understand very well. But that's just a rough thing. So I moved morphological and deformations up to the top. And so the morphological model, this was one that was actually really tricky for us to figure out. And I don't remember if we did it as this team or earlier. I can't remember. I think it was this team, but I don't remember. We were really confused in the beginning. We had this idea that models are just like, you build like a model of something. It's just composed of other things at certain locations or poses to a reference frame. And yet we kept bumping into issues like a line drawing, or how does that work? And there was I didn't enumerate all the issues here, but we ended up going to something which I would have never expected, is that the base model in that we learn, or that Thousand Brains project should learn, are morphological. They don't really define what the actual features are. It's just that the position and orientation of the features is the first level of description of an object. And so that would mean, like, if I'm looking at a visual object, it would be the edges of it. But it wouldn't include things that are more qualitative, like color. And it wouldn't even be able to do something like, not very easily, something which was, learning the logo on the coffee cup. It would be more like, oh, there's an object on the coffee cup, it's some orientation, but the model itself doesn't really say exactly what it is. And of course, we do have models of details with these qualitative features. And so, but we have a good model for how this works in the brain. We have the mini columns, which represent the orientation of the feature. And then picking individual cells in those mini columns gives us almost an infinite number of, almost unlimited number of particular instances of a morphological model. So I could have a morphological model that describes the edges and boundaries of an object. And then I could have many, many different flavors of it using the same morphological model, because it's the same set of mini columns that are active, but we can pick individual cells within those mini columns to say this is a particular cup or this is a particular item. Also, it allows us to recognize objects when we don't have those qualitative features. So it explains why we can recognize an object when it's black and white, or we can recognize an object that's in some sense missing a lot of the details we typically associate with it. It also explains, of course, how we recognize line drawings, and we often talk about a face made of fruit, or vegetables. It's like we still see it as a face because the morphological model is the same, even though the individual features, they have the right orientation, but they're not the right features. It's not a nose, it's a pear, something like that. So that was the first thing we wrote about morphological models.
I guess on that, I kind of stumbled upon that topic again too when I was thinking about deformations earlier. And I think one thing we talked about maybe like 1 or 2 years ago a lot, but I'm not sure if we ever like incorporated into the theory, is like whether the morphological models are kind of separate from the feature models, and we can kind of mix and match them easily. So basically that the morphological model, no matter which features are on them, will always have the same object ID. Like the cup, doesn't matter which logo is on the cup or what pattern is on the cup. If it's shaped like a cup, it will have the cup object ID. But then you can apply a bunch of different feature maps onto it. So just kind of how that would be disentangled.
Right. I mean, did you come up with an answer? I have some thoughts on it.
Well, I came to the conclusion that if we can disentangle it, it will solve some problems, but I didn't come up with an answer of how we would disentangle it.
This also gets. Go ahead.
I was just wondering some of the problems, like some of the recent ones, or some of the older problems around.
I think it would solve some of the object distortion problems.
Well, I mean, it does play into object distortions, because when I was asking myself, or deformations, I use the word deformation, is that okay? Is that the same thing?
Yeah, same thing.
I said, well, what are we deforming? We're deforming, I believe, my first intuition is we're deforming the morphological model. And so you can apply deformations to a morphological model and then particular ones would carry over their features, right? So, you know, it also gets to something that Niels has brought up many times, which is, you know, well, at least in the past, the issue of classes of objects. And it felt like, well, this is a sort of class. I could have, you know, a class of objects that share morphology, and that's what a class is, and they have very different features. But I also, that class has to include deformation. So it's something like there's a morphology model, you have a deformations you can apply to it, and you can also apply individual feature sets to it. And that seems like it might cover the universe of these things. It's interesting in the biology, the way we always, when we first started this, the temporal memory algorithm, which is the algorithm we think is being used for this, even though it's sensory motor, we assumed the mini columns themselves were the actual detailed features, but they never met the biology. The biology always said, oh, the mini columns look like orientations. They're like, there's just not that many of them. In our first paper on the one that, you know, why neurons have thousands of synapses, we mapped out features onto many mini columns as an SDR type of thing. But that's not right. That's not what it looks like in the brain. So this fit all of a sudden, oh, we have this, if the mini columns are just orientation, that's great. And then the individual cells would be, you know, because of sparse properties, you could have many individual representations of those mini columns. But then we have the question, I think, I'm getting to the point you brought up, Vivian, which is, when I want to infer the object, what am I inferring? Or what am I labeling? What am I not inferring? If I wanted to create a class, an ID, well, we assumed that there was a temporal pooling going on in the upper layers, and so we were temporal pooling over the individual cells. So that the algorithm we outlined would say, oh, I have a label for this specific instance of this object. But we also want to be able to say, oh, it's a generic object, it's a cup, not just the Menta or the Thousand Brains cup.
Yeah, I think, at least for what I was thinking about, it would already be sufficient if just all the cup-shaped objects would be in the same reference frame. Like if we can use the same like unique location space for like any features that might be on the cup, then I think it would be okay to then pool it into different object IDs, but as long as they would be in the same reference frame, it would solve some of the issues of object distortions or.
Well, okay, so this is, I wish I could, I'm not drawing, I could try to draw on a scale draw, but it might take me too long. I think this is a very similar issue. So the issue I was just about to bring up is that at one level, you'd want to be doing this temporal pooling over mini column activations, because that would be the ID of the, maybe the idea of, well, I don't even know how that works. It's like you want to be able to do temporal pooling over the cells, and you want to have a unique representation of the mini columns. You want to have a unique representation of the cells, and you're just suggesting something same for the reference frame. You want to have a unique representation for the class of objects of cups, and you also want to have a unique you want to be able to somehow tie that into a reference frame that was specific to specific cups. So there's this duality we're talking about between, you know, the class of the object, which is just independent individual, you know, it's shared among many objects, and the reference frame would be shared among many objects, but then we want to be able to specify specific versions of it. I have images in my head as I'm talking about this. So I think it's a good point. If I would say your point is, we should be able, it would be great if we could treat the morphological object as if it has its own reference frame, and that we can path integrate to it, and we can temporal pool over it, but we also want to be able to do the same for specific instances. Does that make sense? Is that what you were saying?
Yeah. Basically having the ability to kind of apply a bunch of different, I'll call it feature maps onto a morphology model, but then also having, like, no matter which logo is on the cup, it will activate the same mini columns and same locations in the same reference frame on the morphology of the cup model.
The problem we have is, if you imagine we had a reference frame that was just for the morphology model. It's like the class reference frame. Well, if I know where I am on that reference frame, how do I make a specific prediction for a particular instance, right?
Yeah, I guess how I would propose it could be is that we have one reference frame for all instances of mug-shaped objects, no matter what the features are on there. So that reference frame is for anything that has those particular orientations at those particular locations. And then whatever cells we activate within the mini columns can be like additionally conditioned by the specific object ID or by a feature map ID that tells you, all right, if I'm on this feature map and on this morphology, then at that location I should expect this particular feature.
Right.
Yeah,
I'm thinking about neurons. I don't have the neurons do that. Maybe you can do that easily with software.
I mean, wouldn't just like apical kind of
yeah,
sort of biasing do that?
Yeah.
But I guess it's also with the top-down feedback, because that would also potentially be unique. Which I don't know. Yeah, in general with the feature maps, because I feel like we kind of avoided the need for feature maps by having the point-by-point compositionality, which so with the logo on a mug.
I'm not sure what you mean by feature maps. Maybe I'm.
What, at least my interpretation of what you were just describing, Vivian, of having like some sort of large kind of representation that you kind of wrap around the morphology model or kind of bind to it. Like that's kind of what our the hierarchy is meant to be doing.
Well,
right. It seems
but I thought in hierarchy, the object ID of the child object is also just specific activation within the mini column. So that would be treated as features, which I was thinking of as like basically the feature map defines which specific cells you would activate in a mini column.
I guess I'm just confused where we need an additional feature map representation. Like what's insufficient about the compositional like the main one where it makes sense to me right now is like if we want to say like, okay, the color of this object is like blue, so we want to, or it's like covered in checkerboard patterns or something, so we want to predict that everywhere without having to do a bunch of binding, which I feel like could be something like relatively simple happening in L4 or something, just about like I don't know if it's necessarily a feature map, but it's just like keep predicting the same thing unless I tell you to learn something different.
Maybe after we go through the document, I can just draw some of the drawings I made on Excalibur, and then it might be clear when I'm talking. It's a bit hard to describe with words.
I think just before we go on, it's tempting to think like this can be solved in the hierarchy, right? Because that's the way you can relate two reference frames to each other. And that mechanism feels really good. So I think that's what you were suggesting, maybe, Niels. Anyway, so I just wrote down some ideas here that we got these two, so I'll just call them object spaces, the morphology and the detailed, and I call it something else. And then how can they share a reference frame? And it seems like we need to be able to fluidly go back and forth between these two. Like, we need to be able to pattern negation in one, but predict in the other, but maybe we can't predict, we can do, if we can't predict a specific one, maybe we predict just the morphology. There's a lot of things like that happening. I think it's also worth, I'm just going to say here, can hierarchy solve these problems? One thing before I go on again, one thing I realize is that, when we can learn an object with vision and then infer it with touch, or learn it with touch and infer it with vision, we can only do so with the morphology object, because the qualitative features of touch and the qualitative features of vision can't be shared. So it's like, okay, so I end up somewhere of this, when I learn this thing, I end up with a model of an object that is shared across modalities, but that one is really just a morphology object, or at least I think it is. It certainly can't have color or texture or temperature, things like that. So that's another way of sort of thinking about it. And if I think about hierarchy, I would imagine this pure morphology shared model would be higher up in the hierarchy because it's across modalities, or it could be voted on across modalities. But anyway, okay. So I'm just spouting ideas here. So can hierarchy solve? So this is a good idea here. Anyway, so it felt like then we've been talking a lot about deformations. Did we cover everything I wrote about morphology here? Yeah, let's see here. Yeah, and deformations, this is the one that, you know, whether it's on the spectrum of t-shirts to bent logos to Vivian's balloon. These are all kind of confusing. So I said the examples are a flattened ball, the bent mug, a crumpled t-shirt. I made the observation, I don't know if it's true. I said, oh, in all cases, the relative positions of features is maintained. But the overall morphology has changed. So, you know, the relative position of two things on a t-shirt or on a bent logo or something is it hasn't changed. It's just the morphology has been messed with.
You mean like the neighborhood relationships of
right, between features, the neighborhood.
Like the distances might have changed, but
right.
I think we're next to each other, are still next to each other.
There's some concept of it's like as you suggested, you could stretch the reference frame, and if you stretch it, as long as you just keep stretching it and don't break it, then the features go wherever the stretching takes them. That's what I'm talking about, right? You know, if it's three features A, B, and C in a row, they can't become A, C, and B. They can get stretched out or they can bend, but somehow they're still if flowing through some space. They're still in the right orders. And of course, on a t-shirt, they could fold on top of one another, but if you follow the surface of the t-shirt, they wouldn't be out of order. So it struck me now, again, it's just, I may be wrong about this, but it seems like we had two possible explanations. One was it was sort of like the compositional idea where I said, hey, the logo you can take an object like a logo and apply it to any morphology model. And so you could take the logo and wrap it on a mug. You could take the logo and wrap it across the top of a car. You could put it on a sphere. And so the idea there is you have to have a hierarchy, and you have a morphology model in one region, and you have the specific object you're modeling in like the logo on the other region, and then through hierarchical connections, you're basically using the morphology of one region to do the path integration, and then go back and pick up the assignment in the other one, which is the specific thing like the logo. So that was one idea. I still think that's valid. It has a lot going on. You proposed, Vivian, a different one, I think, which is sort of more of a deformation of the reference frame. It wasn't like the reference frame was deformed, but the reference frame, the how you update your location, orientation, and direction through path integration would be modified on a point-by-point basis, which is pretty much the same as deforming the reference frame.
Yeah.
And
so
that has, yeah.
Yeah, it wouldn't actually involve the thalamus itself to do that, but and yeah, like you said, it would just update the location you expect to be in instead of actually deforming the reference frame. But yeah, it's similar.
I thought originally you suggested it was done through the thalamic projection. That's why I like
well,
it.
I didn't say where it would actually, I'm not sure what the best connection for it would be, but I don't think it would require the thalamus. It would just require sending a movement command to the child object's reference frame.
Well, all right, but the thalamus is already doing scale, and we think it's doing scale and orientation changes. And I thought originally when you proposed this, you said, oh, we could just do it on a more point-by-point basis in the thalamus, and that's one of the reasons I like that theory. That's one of those, you put it out there, you say, this may be crazy, you probably aren't gonna like it. Oh, I do like it. And that was because of the thalamus. If you hadn't brought the thalamus, then I probably wouldn't have liked it as much. Anyway.
Yeah, so I actually didn't see it as an alternative to the compositional solution. It kind of builds on the compositional solution.
Oh, really?
But I tried to make a visualization of it, which I can show later, to show kind of the similarities and differences. But yeah, what you wrote is pretty much fitting.
Yeah, I still like the compositional thing.
Yeah.
Because it's a mechanism we're pretty certain exists, and we're using it already, and it'd be nice to use it again. And just like we were talking about, the relationship between morphology models and specific models, and maybe that could be solved with hierarchy. This is very similar to that.
Yeah, so the mechanism I was proposing basically takes the compositional solution and then adds an additional mechanism for updating location instead of predicting orientation changes only.
Yeah, I guess I'm not sure how that would work if you didn't go through the thalamus, but
I thought when we last talked about it, it felt like it would be easier if we didn't go through the thalamus, because it is like a translation rather than a rotation or a scaling. So that actually feels like something that fits better in L6 or something like that within a column rather than
So my preference, it's just me, and I don't, I get 1 vote, maybe 1.5 votes. My preference is like, I don't want to introduce a new mechanism if at all possible. I'd rather just camp on the existing one, or even a new concept of like, so I'm just, maybe I still don't understand it well enough, but it feels like, this is a whole nother thing that we have to somehow get these cells to do, and we're asking a lot.
But that's the thing, like that's what L6 cells are already doing, is integrating translation, integrating movement, whereas we've never talked about the thalamus doing translation.
Okay. Fine. It didn't feel right to me. It doesn't feel right to me now, but I think we can make the case, and maybe there's an in-between, like you said, maybe it would work. I just feel like I want to start with the idea that can composition solve this problem? And if it can't, and you want to add some additional details to composition, well, that's good. I go for that if I'm convinced that the existing mechanism somehow doesn't work or it's insufficient.
Yeah, I think I didn't do a very good job on explaining how it relates to the compositional mechanism and how it works. So maybe I can clarify it a bit later.
Anyway, I think this is an area we don't really understand. It reminds me a lot of the confusion we had before we kind of understood there was these morphological models. That was, as I said before, there's not an easy thing to come up with. It was not an easy thing to think about or accept at first. But then it kind of made all sense. The biology supports it and looks right, so on. So this reminds me of that. It's like, there's something weird going on here, and maybe it's simpler than we think, and it's just like a different way of thinking about it or something. I don't know, but right at the moment, it's confusing to me.
One thing I've been trying to think about, it's too early to present, but just, whether kind of something more just like associative connections between like certain cells in L6 or something could do something kind of similar. And that, I don't know, might be it might have slightly different properties and also kind of help with some of the biological plausibility, but I'm hoping to try and write some of that up. But
one thing, if we can still brainstorm here, when I was thinking of examples of deformations, and you had that one where the cup was bending, remember? The whole cup was bending. And it occurred to me, like, it feels like I already have some pre-learned memory of that shape. Like I've seen that shape before. So now it's familiar to me. I can infer that bent shape of, it's like a bent pipe or bent, straw. I know that shape. And then I was trying to imagine deformations which I didn't know, I've never seen before. And I felt like I'd have to spend some time learning it. It wasn't like, I can just it was almost like I'd already learned somehow that image of that particular bent thing. And I might even know it as part of a behavior, like, oh, that's the intermediate state in some behavior. But it wasn't like I could just take some arbitrary, it wasn't seem like deformations were arbitrary. It seemed like I was trying to fit into some previously learned shape and say, okay, I'm applying it to that shape. That's the bent straw shape or the bent pipe shape. I can now apply this to that. And then I was thinking about shapes which I had never seen before, and it became much more difficult to do the inference and prediction task. That's why I'm just pointing out that I think even those deformations may be recognizable morphology models.
Yeah, that's how I can get back to the morphology versus feature model idea, because I feel like if we can separate the two, then pretty much all problems could be solved by just recognizing a different morphology and projecting a certain feature model onto them. Like with the bent cup, you might just recognize that bent morphology, and then you project the logo onto that, which will automatically bend with it, and you project whatever other colors are on the mug.
Right.
Right.
So the big point. Go ahead.
I think it. Like I guess I went through a little bit more dangerous territory because I thought now I think that morphology models might be. Anyway, so related to what Vivian said, like we might need to also do kind of backwards where we project morphology into some features. Like I was thinking about mirrors. Like mirrors can have so many like different morphologies, like bathroom or handheld, but the share the same feature of like something is like reflecting. So it's not that we're kind of like I don't know, like I don't know how to handle that where like okay, I don't know if I have like a morphological, I guess morphological models of mirrors, but I guess they kind of share
Right, so you got me
functional
confused with the
affordance.
mirror. So let's step back and say this again. I got confused.
Okay, so the morphological model of a mirror is so I can imagine us grouping like mug-shaped things.
Well, yeah,
But
a morphological model of a mirror is weird. I don't know what that means. I mean, you're saying a mirror image?
Isn't that more kind of
no,
like
like
an
the
affordance
actual,
almost? Like the
yeah,
fact that
yeah,
something illuminates?
yeah. Like I
Like
mean,
that's,
like
or the
literal
fact that something
hand
is a
mirrors
chair and
or
you can sit
bathroom
on it?
mirrors or
Okay, I have a
body mirrors.
morphological
Like
model of a hand mirror. Okay, I got that.
yeah, but there are so many different morphologies of mirrors. There's like the handheld versions. There's the bathroom mirrors. There's like the body, and I think that it can be like weirdly bent or something if you go to like mirror houses or something like that. So in that case, the morphologies that a mirror can take is wildly varying.
Well,
But
right. Again,
the
I think you're mixing two things up, aren't you? One is just saying the shape of a handheld mirror. So I can imagine handheld mirrors, right? And now you're saying the shape that the mirror produces if I'm in a funhouse. Those are two things, aren't they? Two separate things.
are they two
No,
different
I think
IDs?
it's more the fact that you're saying that like all these mirrors have the same property of reflecting things. And
Yes.
that's why I was saying that I feel like that gets more to like the thing we discussed before, which is like you can also classify objects more on something like affordance, like the fact that a vessel can hold fluid, like vessels can have
Yeah,
millions
yeah.
of different morphologies. The fact that you can eat something, and like at least briefly when we talked about it in the past, I think our feeling is like, yeah, that's probably represented as an ID as well, but it's something different, like whether that's in a different layer in L2, L3 or what it is, but it's kind of learned in a different way, like context and whether you can use something for certain tasks and things like that. But I feel like, yeah, what you were talking about, Vivian, with like a feature map is something different. That's
Okay.
I think if I understand it right, it's actually a good example of applying features to different morphologies. Like you have all these different shapes, but you're applying the same features to it, which is the kind of reflective surface. So you can apply reflective surface to all kinds of shapes without problem. And the reflective surface is in this case a feature, and then that is can be on a bunch of different morphologies.
Yeah. Yeah, so yeah, maybe I'm on the side for disentangling morphology
I'm
features.
finding the mirror
I don't know.
example difficult. I'm not sure how to.
That's fine. We can drop
I
it
think
for now.
the mirrors may be adding a lot more complexities because it will have to model like what's in front of it and what is it reflecting
Yeah.
and stuff like that.
I'm fine. Yeah, to me, it's like it's not working for me because it's
Yeah,
there's so
but
many things
just
going
briefly to
on.
mention on the logo, with that being like a feature map, because I feel like doesn't the logo have a morphology as well? Like that's how
Well,
we
it
recognize the
does.
logo.
But once it is just an object ID on the parent object, then it is a feature map. Like where does the logo exist?
Well, that's why I'm confused how that's different from just the hierarchy we have at the moment. But yeah, again, maybe the drawings you said will help.
Yeah.
And maybe we can just go to drawings now to just
If you want to, I can stop sharing if you want, but
Well, I think you only had like one more
okay, I
topic
can
out, so
try
we
to
can.
finish up here if you want.
yeah,
I
go
thought, yeah,
ahead.
the permanence one was interesting.
Right. Permanence is one. It's just sort of a real practical thing we have to deal with in our systems, and that is, you know, the world, as they say here, has varying levels of permanence. Things are always changing. In fact, I couldn't think of anything that was permanent forever. So it's just the scale of relative permanence, and meaning the structure can change over time for various reasons. You know, it could be objects are moving, it could be a behavior. It just anyway. I was thinking mostly objects are moving. So I gave some examples. You know, one that you know I think about all the time is I'm about to cross the street on my bicycle near the coffee shop where I work, and I have to look around and see, are there other people on the other side of the street waiting to cross with me? Are there cars in the turn lanes? And I quickly look around and I build up this model of the intersection. And it's unique every day because, you know, there's different cars and, you know, maybe someone's got a stroller, whatever. And I built this thing up very quickly and I use it to act appropriately in the intersection. And then I never, you know, it goes away, it never occurs again. And this is a really important part of living in the world, right? And so our systems have to be able to do this. And so it does bring up the question that was mentioned earlier. Scott mentioned it, which is like, I'm just thinking like, okay, the system has to be able to deal with various levels of permanence, and yet not get confused, and has to somehow know that some things should be the same because they always are the same, and some things are always changing, so I don't expect them to be the same. I mean, if I went back to the same intersection 20 minutes later and all the same cars and people were there, I'd be like, oh my God, I'm, you know, taking drugs or something. So I just thought it was an interesting problem of the world. And when I think about, there's different ways you could solve it, I suppose, but in the brain, it seems to be that there are some parts of the brain that are just dedicated for quickly learning models and forgetting them quickly. And that's generally the hippocampal complex. You know, there's some evidence other parts of cortex can do quick learning, but mostly we associate it with the hippocampus. And we think the hippocampus works basically on the same principle as the cortex. It's not exactly, but basically the same basic ideas are going on there. And in biology, you have to break it out. At least you have to break it out because it requires a different biological mechanism to learn these things very quickly. But that may not be true for Monty in the Thousand Brains project. And so really the point of this is to say we have to, as we think broadly about Thousand Brains and building robots and intelligent machines, this is a very important practical issue that we have to deal with. Quickly learning models, and then and some can have to be permanent or semi-permanent. And then it occurred to me like, well, if in a computer, I suppose we don't have to get rid of previously temporarily learned models. We could just store them in some data store someplace, so that if I wanted to, I could go back and say, oh, on you know, June 17th, at 9 in the morning, what did the intersection look like? And I could recall that, where a human can't do that, but I suppose our Monty systems could. So I just thought it was worth bringing up, so we all at least are thinking about it a bit, as an issue we have to do. and the brain provides some insights to how we might go about it, but I'm not sure the brain's particular mechanisms for handling us are essential for 1,000 brains. So that's it. I just didn't want people, I want people to think about it.
I was kind of thinking about something along similar lines when working on these mug stuff in Blender recently and making new objects, and saw that you can make random surfaces. And I thought, Monty could learn all of these random surfaces perfectly.
I don't know what you mean by random surface.
So it's a mesh, just a 3D mesh, and you can click a button and it just randomly generates one. Like,
So what? It's like a folded T-shirt, just does some weird thing.
yeah, just imagine like a big spiky surface.
Okay, so it's like take a reference frame that represents a T-shirt and just crumple it up. That
yeah,
idea? Okay.
yeah. And I was thinking, Monty could learn all these perfectly as it is now. I
If
couldn't.
it had enough time.
Yeah, if it saw them individually, it basically would memorize that's basically like memorizing noise in a sense. I wouldn't be able to do it very well.
Well, I mean, I think the combinatorial problem of remembering all the ways a T-shirt would crumple are impractical, right? It's more than the number of atoms in the universe type of thing, right?
Yeah.
So I mean, you could learn one or some number of them, but certainly not all of them.
Yeah.
Yeah. Right.
I was
But
just thinking that, there might be features about the object to help inform, like, especially, I like this idea of a shared reference frame. If there are features about the object that help put it into a shared reference frame with other things, then that shared reference frame is a space where we can sort of operate temporarily in and not necessarily need to be adding new features to it, like that particular baby stroller in the intersection or whatever. It's a vague thought, but
Can you say that again, sorry?
I led to I have a vague understanding to match with your
Yeah.
face.
Yeah, so I started thinking about the morphology, these sort of like zoomed out coarse versions of the morphologies, right? Especially in an unsupervised kind of setting where I'm looking at a new mug, and if I want this mug to sort of be learned and recognized in a way that's like aligned with my general mug model's reference frame, I can use the coarse features of the reference frame in sort of a model-free way to initialize the axes of the grid cells and the scale and all things like that, and sort of help try to put something into a common reference frame. And maybe having a common reference frame is a way to
I'm still Scott.
maybe I'll try to write this up. This is
You can
probably
write up a
better off.
something,
Yeah.
maybe, right?
Okay.
Right. It might be helpful.
But yeah, maybe it's worth briefly just mentioning, like, I guess the like common reference frame, a nice appeal of that sometimes has come up is this issue of kind of the search space when you first start recognizing something.
Yeah.
That like you have all these objects you're trying to search over, and that maybe that could help constrain that. And also, like, it doesn't seem biologically plausible that we can search in parallel over all these objects. But yeah, that's maybe just another reason to kind of think a bit more about that idea.
Hey, can I just throw an idea? I thought of it, and just so I don't forget it. Someone can remember it for me. There's a classic example of a problem like you're looking for a place to sit, but there are no chairs. But then you find things that, what can I sit on? Or you might see something and say, I can use that as a chair. Or you might say, that's a different chair than I've ever seen before, but I know I could sit on it, or something like that. And that made me think about is like, what you're doing is that's almost like, let's say you have a chair morphology model, your classic chair, and now you're willing to, you can morph it, deform it into different ways. And maybe if I'm looking at another morphology model, I could tend to a subset of it, I could then see that subset is similar to the chair in the same way that that behavior models are a subset of the whole overall model. Anyway, it's an interesting problem to say, how do I see something, say, oh, that's good enough to use as a chair. And I think it's the morphology models have to, you have to be able to look at it.
I
That
think
just
I do
reminded
the
me-
opposite. I take a model of
Right.
myself and try to imagine it sitting down on the object. And then, like, instead of trying to take a model of a chair and matching it to the object.
I didn't say I
agree.
would take a model of a chair. It'd be more like, well, I'm looking for a place to sit. I think that's the starting point, right? I'm looking for a place to sit. I guess I am looking for, you know, a sittable thing. We can call that a chair. I don't know. It's gotta have a horizontal surface at a certain height, and maybe a back, maybe not. I don't know. Maybe I'm
Yeah.
not sure. Maybe just.
I feel like to
I think
determine
that,
whether it's sittable, like that's where you do the mental simulation. Like, yeah, you might bias your search for chair-like objects to help you be
Right.
more efficient, but like you know, almost anything could be a chair under, or you know, or so many things, or like so many things could hold some liquid or whatever.
All right, maybe it's not a good. Let's erase this example. Forget I said
I mean, it's fun because that it has an extreme example because I recently sat on like those like medicine ball, not like those huge like yoga balls in gym, like where you can do things like, and that ball is not doesn't have any morphology of it, doesn't have any flatness. I guess the only thing is that if you put your weight on it, you can't sit on it because I guess I did
It's a
with
pretty
some.
bad chair. I think you'd roll right off, wouldn't you?
Yeah, it's it trains your course. That's the whole point, I guess.
It's supposed to be actually pretty good for you to sit on those as an office
It-
chair.
yeah,
Right, but
anyways,
I think it's a
yeah.
different thing than sitting. I think
Yeah.
I realized I was conflating two different things. One thing is a classic example of chairs of different shapes and morphologies, and how do you all know that they're all chairs? You know, they can be Baroque, they can be this and that. And then that's really a separate question than finding a place to sit. It's not the same thing. I was conflating two things. All right, I'll take that back. I do think the idea that on an object, we might see a subset of it, the morphology of a subset of it is recognizable as something we know already. In the same ways that, you know, behavior can be a subset of a bigger object. Again, composition would play place. Okay, I'm rambling. Sorry about that.
I guess I
I
had one more thought on what Scott said about the kind of random objects generated in Blender and the crumpled t-shirt and stuff. And it reminded me of the solution we suggested for the practicality of learning object behaviors, where at first you learn very few points of the behavior and you try to interpolate between them to make predictions. And it seems like that would also apply with learning morphology models and also learning distortions of morphology models, where if the object is sufficiently simple, like let's say you have a random shape, but it only has like 6 edges, they might just be in different locations than on a normal cube. That would be relatively easy to learn, I would say, quick to learn, because you could just store like 6 points or a couple more and then interpolate between them to make rough predictions. But then if once there is more and more complexity, like 100 edges on that weirdly shaped object, you need to store more and more points to be able to make accurate predictions. Similarly with the t-shirt, when it's crumbled, there are so many little local changes you need to learn to make good predictions that it's difficult. If you learn, but you can learn a coarse model of the overall shape of the crumpled t-shirt, like whether it's like L-shaped, crumpled, or in a pile or something like that, and make those kind of rough predictions. So yeah, I guess just kind of reminded me of that in terms of Monty, that maybe like gradually moving more and more towards learning like models with very few points and interpolating between them to start with, and then only if it's really necessary, learning adding more points or higher resolution in certain areas.
Yeah, I think that's a good point. That's a theme that we see everywhere. You know, that's like the example often I use is like, you know, recognizing trees. When you're a child, if you don't know anything about trees, they all look kind of the same to you. And then as you get better, you learn to know what details to look for. And then you sort of fill in those details later. It doesn't throw away the original model, you just can add more stuff. It takes some time and memory, but Anyway, I think that's what you're saying.
Yeah, I have a thought on the topic of permanence. I see this clear distinction between permanent models and temporary models, and it makes me think that perhaps it's more of on a spectrum of how things are permanent or temporary. Like
I didn't I say that wrong? I said it's a spectrum. There are no
oh,
permanent.
you didn't.
Yeah,
Yeah.
yeah. I couldn't think of anything that's completely permanent, and so it's just a spectrum.
Okay.
Yeah, right. I'm not sure.
No, so I'm wondering if it relates to the problem of keyframes in a behavior where, you know, so if we think of one keyframe that we always see, like maybe very frequent as like a permanent arrangement of these orientations, and then as it moves, maybe we have another keyframe, and that's another semi-permanent arrangement, but all of the others are like temporary. And I'm wondering if the two problems are kind of related to each other.
I didn't think of it that way. I thought in the behavior, you don't learn the morphology as the thing is moving. There is no memory of the in-between states unless it stops or it's going very slow. And if it stops temporarily, then you can say, oh yeah, I get it. I can learn that as a morphology model. But I don't think we're learning and forgetting the in-between ones. That doesn't feel right to me. It doesn't. I mean, maybe you think that's right. I don't know. It doesn't feel like that way to me. It's like when people used to. There was an old. One of the very first uses of scientific uses of like a video, you know, a motion picture. There was a lot of debate about when horses ran, exactly what their feet were doing. No one could figure it out. Because as a horse is running by, you just can't see it. It's only when they actually took video, or motion picture of a horse, and you look at each frame, then it resolved this big debate about what the horse's feet were doing and its legs were doing.
Yeah.
And so that's like, there's no way you can see what the morphology of the legs are as long as the horse is running.
That's
That was
great example.
Yeah. And I'm just wondering if it's more of a statistical thing where, you know, if you see something 90% of the time, it has this permanent, it becomes more of a permanent model that you can store. And, you know, if it happens to change a lot, you basically don't store it.
right. Well, that's the basic biology, right? That, you know, Hebbian learning is that, you know, with repetition, it actually, this was in the neuron paper we wrote. It was an observation that some other scientists made once. I don't remember who it was, but it was really insightful. They said Hebbian learning is not really about increasing the strength of a synapse. It's about increasing the permanence of a synapse. So it may release the same number of vesicles, but the synapse itself becomes a thicker structure, and it gets this really, you know, permanent physicalness to it. And so the idea is that, you know, if you've repeated something over and over again, or if it's done in some sort of emotionally salient context, the synapses become permanent and they don't ungrow very rapidly. Whereas if you just see something a few times, you get this little filament that can go away. But it's not like strength. It's all about permanence. So there's a basic understanding of the mechanism, although many neuroscientists don't really understand this still. Is a complicated formula about what leads to the permanence of a synapse. Again, emotionally salient things are remembered very strongly, even with just few exposures. But generally, you have to expose something over and over and over again. And if you do it enough times, properly, then it'll take much longer to go away. This is, you know.
Yeah, that makes sense.
You got memories from your childhood that sort of stick around, even though you haven't experienced them in, you know, in my case, a lot more years than yours. But, you know, decades. Yeah, you know, it's interesting to think about Monty and how we would implement all that stuff. I don't really know. Clearly, we're not doing synapses right now. And we modeled it in the neuron paper of just a variable called permanence. As
Yeah, I
opposed
guess
to
the closest thing we have right now in Monty is the grid object model, which basically kind of only adds points to a model permanently in like the top K locations where they were observed. So only the most consistent features on an object will become part of the model that's used to make predictions.
Well, again, it may be required to have some sort of forgetting going on.
Yeah, and then if other features are more consistently observed, then the ones that are less consistent will be kind of dropped again.
And maybe, you know, I don't know, do you have things that become permanent, or is everything on a spectrum, like Romy said?
Well, right now in the mechanism, it's like a top K kind of mechanism. So if something else becomes stronger, then the lower ones
Okay,
fall off.
so it's not, there's no
But,
permanent.
yeah, it's not like an object would at any point be completely forgotten. It's more like the locations that we use to represent that object. Yeah, we don't have a lot of like forgetting in Monty right now.
Right. You know, another thing related to this is if you think about like the hippocampus, you know, and it forms these episodic memories very quickly. You know, I'm sure that's where I'm storing my memory of the intersection while I'm in the intersection. And, you know, and I can recall that even an hour later, I'll recall details of the intersection. It's not like it's lost immediately. But anyway, if it's in the hippocampus, basically I'm already, the memory in the hippocampus is already it's a composition of other high-level objects, right? Cars, people, strollers, even people, I can look at someone and say, oh, what's their intention? You know, it's a child, or that's a parent with a child. I have different, it's very high-level objects. And so the whole rapid memory is built on the fact that I have already a very, very good model of all these things. And so if my models are to change in the brain, it's okay to change them at the top, you know, at this sort of hippocampal level type of thing. But I don't want to change them in V1 or V2 very often, because if I do, then everything above it gets blown away, right? So, you know, if I forget what you know bicycles are, and all of a sudden, you know, I have a new memory what bicycle is, you know, all my old memories that are based on bicycles are going to get really messed up. So anyway, there is this sort of hierarchy of permanence that seems to be required to keep your sanity. You know.
Yeah.
All right, we can if you want, I can stop sharing my file here. You know, it's funny. I wrote a whole bunch of stuff on composition, and I said, we already know this. Why am I writing it? I'm just repeating what we already know. So I deleted it all. I don't think we have everything. We have more things to say about behaviors, and I have more things to say about spatial and temporal structure, but I didn't get to it. So anyway, if someone else wants to bring up CalDraw.
Yeah, I could go over what I drew, but I saw, Hoja, you also drew some stuff. I'm not sure if you wanted to go over that first or.
Not really. I mean, I think it makes sense to, before I forget, like what we were just talking about in my memory. My short-term memory is very short, and my long-term memory is also kind of short. So just to keep it in kind of context of what we were talking about. Yeah.
Okay. Yeah, so I kind of have two things I drew on here. One is after reading your document, Jeff, I realized that I didn't really make it very clear what the kind of proposed solution was and how it related to the compositional model solution. And I went back to this document and I realized I never really showed it how it relates. I did write that it is as in our standard hierarchy framework, but that was like in a bracketed comment. So I tried to make that a bit clearer. And then the second thing is that I just kind of tried to think about circles and ovals, and if we can kind of solve this with pure morphology models, and that's where I kind of had the thought about like separating morphology and features a bit more. So actually, after thinking through the second one, I'm not 100% convinced that we need this mechanism anymore. I guess I think I have to think
Maybe-
more through it, which way would be easier. But yeah.
Yeah, interesting. It's my bias, then maybe it would be more like especially interesting to start with the second stuff, but I don't know what you think.
Yeah, so I
But
guess
yeah, so
the second one kind of
if you
ties
feel it
into
kind of supersedes the other stuff.
Is the second one the circle thing?
yeah.
Yeah, that's like
And feature map.
Seems like the circle seems to be the hardest thing in the world to understand.
Well, it was really more like an afterthought after I applied the like proposed solution to circles and ovals. So it's kind of just this orange text, basically saying that, okay, so the whole point of modeling these object distortions in a separate model from the morphology model, the whole point of that is that so you can apply the same distortion to different models. So basically, I can learn this kind of circle to oval distortion, and then I can apply that to like a ball that squishes, and that can have like the logo on it. It can be striped, whatever. That distortion applies to anything that might be on there. But then, as I was trying to put some images of examples on here, I realized that all the examples I could think of were just like changes in features on that morphology. Like all of them would still have the same oval morphology. So the thought was just that if we could basically just learn separate morphology models for the circle and the oval instead of learning the circle morphology model and the oval distortion model, and then apply any kind of feature map onto it, we wouldn't.
Is that what I was saying earlier? It was like we just learn these as separate objects.
Yeah, exactly. Yeah. So we would basically, so here blue represents a morphology model that's basically defined by orientations at locations. So we have the circle, and the model of the circle is defined by these specific orientations at those specific locations. We have an oval, and the model of the oval's morphology is defined by those orientations at those different locations. So that's kind of option one. We just learn two separate models for these two shapes, two different morphologies. Option two is we learn just the morphology of the circle, and then we learn how to distort it. And I just went through an example for that. But then basically, what does this help us with? Wouldn't we have to learn an equal amount of distortion models as we would have to learn morphology models in option one? Yes, we would have to if we just have ovals and circles and they're all just morphology models. But it helps a lot once we start applying the same distortion to different models. That was kind of my reasoning.
But can I interrupt right now?
Yeah.
Why couldn't we view, instead of calling it a distortion model, isn't it just a behavior? I have two morphologies, the circle and the oval. We got these two things. You know, I could have just learned them separately. I see circles and I see ovals. Or I could have said, oh, this circle becomes an oval, in which case then it would be a behavioral model.
Yeah.
But I still would just have I still have the two morphology models because I observed the circle and the oval after it's been squished. I'm just saying it just feels like the transition is really just a behavioral model. It's not a distortion model. The behavioral model could say, oh yes, I can go. Sometimes these go between these two, but they're still two separate morphology models. What's the difference in a behavior model and your distortion model?
Yeah, so I didn't get around to that. That was the third item on my list to think about today, the relationship between the two, but I didn't get around to that. But I think they are very related. I guess the main problem I see with this just being a behavior model is that I don't really know yet how we would use that to then make predictions about the morphology.
Well, I'm not sure I would. Well, I could. Look, imagine I have two morphology models, circle and oval, and they just are separate things. And then I say, oh, a behavior model if I see a behavior, then I can then predict the morphology model, the resulting morphology model. It's just a way of tying them together. It's to predict the next morphology model. And so it's like saying, oh yeah, well, these are tied together in time sometimes through a behavior, but they're still separate models, still separate morphology.
Yeah, so you are saying you would have both of those models, a model of the circle and a model of the oval, and then you would have the behavior model that lets you kind of recognize when the circle is transitioning into an oval, and then
the behavior model is optional, right?
Yeah.
I may or may not have it.
Right.
It's only if I observed it.
Yeah, so you're kind of
thing
on the side of option one to learn two separate morphology models, and then optionally you have the behavior model if you often see them transition between each other.
Right, and the behavior model would predict, I could say, oh, well, I know, it's like, think of the stapler. Maybe I have a picture of an image of the stapler in the closed position and in the open position, and those are two separate morphology models. And if I never saw them transition between them, I might think like, oh, well, there's two different types of similar objects, different morphologies. But if I see the behavior between them, then I can say, oh, well, yes, this should be, once the behavior started, I should end up at the second morphology model.
Yeah, and
I
so
guess
the
one thing
problem
just
that I
to,
had with that so far was that, all right, you learned this morphology model and this morphology model on those two objects, but then now you're seeing this circle with the 1000 Brains logo on it, and it's distorting. How do you make sure to apply that? Like, how do you then make predictions about how the features on that object change? And that's kind of where I always got stuck. Like, how do you then have an object with a similar morphology but different features on it and apply that different morphology to it, or that distortion? So I guess if we can kind of think about this path a bit more, about having separate feature maps to be applied to the same morphology, that's what I meant with that could solve all of the issues I was seeing with option one. And I would be very happy with it. Yeah.
Did you want to say something? I have a question, but Niels, did you want to ask a question first?
yeah, I guess I was just curious. So, because I would say like originally our kind of naive approach would be to have just learned a different morphology model for the circle and oval. But I remember you had concerns about that, Jeff, like just that felt wrong somehow, that those would be separate models. So I'm just curious if that
I don't remember.
issue has disappeared or.
Well, I don't remember making that comment, but it's certainly capable.
Okay.
It's certainly capable of making a comment like that. You know, I wear my thoughts on my sleeve, so they
I think it was maybe like, when does a circle turn into an oval? Like, at what point is it a new model? Kind of question.
Well, yeah,
because you could have tons of different ovals, and it's like, do we want to have, different morphology models for all different ovals? I don't necessarily have a concern with it. I think we would probably just learn, like if it's a slightly different oval, we'd probably just learn it on the fly or something like that. Like,
it's funny.
Be close enough to previous ones, but I was just curious.
It's interesting to think like, okay, ovals exist on a continuum, right? But I'm not sure I don't think I have an infinite number of models of ovals, but it's possible that I have quite a few. Like I could have a model of a circle. I can have a model of like the oval, maybe like Vivian's showing it, and maybe a couple other flatter ones or something. I don't know. I certainly don't have a lot of them. I can't have a lot of them. But the question is, if you asked me to draw an oval, I would probably, I might draw the same ones over and over again. Like you draw a bunch, draw 4 different ovals. I might always draw the same ones. Those might be my canonical ovals. I don't know. It's an interesting question. I don't know.
Okay, yeah. No.
I had thought about the distortion here. If I see an oval and I see a logo on it, I don't expect it to be distorted because, well, ovals are their own thing, and I can put it's like a little badge, and that's a lot of logos look like that, like the one you have down there. I don't think that. Well, that one's squished.
I did squish it, but I guess I was thinking of Like you're actually observing the distortion. Like you have a
Well, all right.
ball
So no,
bounces
my
or
point
something.
is, I have two different expectations. If I see a logo on an oval, I don't expect it to be distorted. However, if I see the logo on a circle, and I know that the circle is now behaving, and I actually know that the circle, there's a behavior, I'm observing the behavior. Then I guess I would expect the logo to be distorted, probably. I mean, I would recognize if it wasn't, but it was, you know, if I actually playing with a ball, my grandchild, and we squished the ball, I expect the things on the ball to be distorted. So I don't think there's a single answer to this question. It's just an observation that there isn't a single answer to it. If with the behavior, I expect distortion. Without the behavior, I wouldn't expect distortion.
Yeah, I guess
there's
in a
no
more general case, like if we have behaving object or distorting objects, we'd ideally want to be able to generalize to different versions of those objects. Like if I learned the stapler once in its open state and now I see a different stapler that opens, I would expect the features on that different stapler to move in the same coherent way as features
right,
on the
but
original.
I thought we solved that problem.
Yeah, we saw. So yeah, I was just using that as an example, but we didn't solve that problem for like actual distorting objects like the balloon or the ball squishing, or the cup bending or something like that.
Right. You know, it's interesting. If I saw a balloon, balloons are not just ovals or ovoids or whatever the three-dimensional thing is. That's an object that I recognize, and I know it has a behavior. I know how it got in its current state. There's no question in my mind that that thing was, you know, inflated. If I just saw a ball, I wouldn't think that. You know, I would say, oh, that's ball made like a ball. In the case of the ball, I guess my first expectation is anything printed on the ball wouldn't be distorted. My expectation of the balloon is that something printed on the balloon would have been in a different size or state earlier, and now it's, whether it's distorted or just got bigger, I don't know. But I do know that because I know there's a behavior to the balloon, I would expect the feature of the logo on the balloon or the image on the balloon to change as the balloon changes. This is an observation. It's not an answer to how it happens. It just, so it does seem to be tied to this knowledge about the behavior of an object.
But yeah, maybe like an
Yeah.
example, like a pear or something. Like a pear doesn't have a behavior, but you, like if we are projecting a sticker or a face or whatever onto a pear,
I guess a
I
sticker.
mean, I don't think we can predict it particularly well, but it would definitely
I know
distort
I
it.
have a sticker. I mean, the sticker on a pear is the same as the logo on the coffee cup. It's not distorted in its own surface, right? It's only wrapped around another surface.
Right.
So the sticker is not distorted. It's just mapped onto a different morphology.
Right.
Whereas the balloon really is distorting the logo or distorting the image. It's not. Well, I think these are the way to think about. I think about these are clues, right? All these things are clues as to the solution here. It feels good
Yeah,
today.
it's another.
It feels like we're making some progress. I don't know.
Yeah, I think one other random observation, and this is pure introspection, so I'm not sure how accurate or useful it is, but it seems like when we see a distorted object like this bent coffee mug, you usually kind of imagine how it got there. Like, at least in my mind, it seems like I'm imagining the cup being original and bending into that state. Like any kind of distortion that I'm thinking of, I can imagine how it got there. So I don't know if
It's
that's
funny about,
yeah.
right. Well, we're digging into a little minutia here, but if I saw a pipe and it had bent, I would say, oh, that pipe got bent. That's what happens. Pipes are built straight. If I saw that mug, I would say ceramic mugs can't bend, they break. So it had to be formed that way. I'm just
Yeah.
I'm just pointing out that there's
That's a
subtlety
good
to
point.
this. I mean,
Yeah.
it's like, unless it was a rubber mug, I guess it could be a rubber mug.
Yeah.
I don't know.
But yeah, does it kind of make sense how option one would work? Like basically learning separate morphology models and then using them, like generalizing them to different instances of that object, if we can separate out morphology from features more?
I think that approach is a great one. I mean, Niels did bring up the issue that I suppose that I brought up of like, well, there's an infinite number of ovals, so how do we handle that one? And I was trying to dance around that because we don't want to have an infinite number of morphology models. But perhaps a few would do. And
Yeah, I guess for what it's worth, option two would have the same issue because you would have to learn an infinite number of distortion models as well.
all right, good. Shared burden.
So yeah, so
Yeah.
maybe it's some
Or
combination where, you know, we don't have an infinite number of ovals, we have some small subset. And similarly, the distortions, they can't be anything. They can just be relatively limited, small local changes.
Yeah.
So they sort of
I mean,
interpolate in the short range with distortions,
Right,
and
you'd have to do
yeah.
some sort of interpolation in the short range.
yeah, I mean, you don't do infinitely accurate predictions, probably on those.
Yeah. Yeah.
Yeah, with the distortion, Vivian, wasn't because one of the advantages of that is that you can reuse that a bit more than you can use the separate reference frames in this example. Like that doesn't just need to be used for ovals. That could, I don't know, be
Yeah, I
distorting
guess,
egg shapes
yeah,
and stuff like that.
that's right. One of the other things that I was thinking we could use these distortion models for are more kind of fancy stuff where you have like a blob or whatever, or like you have, I don't know, let's say you have what do you call it, a clay mug. You're just forming it, and then you press your finger here, and it's kind of indenting like that. We wouldn't be, I wouldn't imagine that you have learned a separate morphology model for this indented specific cup, but you can just, you kind of apply a local distortion here. So not sure how that ties in, but
Yeah.
Yeah, that's interesting. It kind of relates
morphology changes.
I
to
keep
what
coming
we
back
talked
saying
about with like separate morphology. Oh, sorry.
what's the word you use for the distortion model or deformation? What's the word you're using for this?
Yeah, like a distortion model.
Distortion model to me is, I think I'm going to just make that into the behavior model. It's like, it's a way of tying two morphologies to a behavior. And so the properties, I'm just stating and not knowing how it's going to work, but the properties, this is what I like it to be, if I could, the properties that you're desirable to have of being able to apply distortion models to new objects should be, if it's the same as we want to apply behavior models to new objects, right? And they really, could it be exactly the same thing?
Yeah, it's very similar. I guess the main distinction I made, why I made it a separate thing, is that behavior models are like a stepwise thing. So if you want to apply a behavior model to a morphology model, you have to kind of step through the whole sequence of changes.
Right, but we've thrown away that idea by saying we're going to remember these different morphology models. Right. So we don't have to do this stepwise. It's just saying, you know, I need to know, I'm just bridging two morphology models. I'm not predicting the second morphology model like by path integration or by, you know, by these trajectories. I'm just saying this morphology model leads to this morphology model through this behavior. So I only have to be able to predict the next morphology model. I don't have to be able to regenerate it on the fly.
Yeah, and then so with like a local distortion like this on the morphology of the cup, would you just kind of apply like a local morphology model of an indent, or like
well, so let's be specific. So we got this mug. I now have a mug that looks like this, is what you're saying?
yeah, like I have a mug made of clay that hasn't been dried yet. And I
Mhm.
take my finger and I poke it into the mug and it indents. And I know how to predict how it will indent and how it will look after I remove my finger.
But now, did you fire it and I have it and I'm using it every day? I mean,
I'm not going that far. I'm just at this
oh,
point. Like, I know how to
It
predict
feels similar
how it
to
will
the
look.
t-shirt that it's like you probably learn like a temporary model, or it might become permanent, but like you could immediately learn that, okay, at that location. But yeah, it's in terms of predicting the distortion locally, it's, I guess you have to apply some sort of like physics type behavior model of clay.
It feels like this is it's just like a keyframe in the behavior model of
Yeah.
stapler. So it's just like you open the stapler and you just left it there. It becomes just like poking the cup and just leaving that indent in the cup. So
Speaking
it's
of
like
which,
Yeah.
sorry.
so just like this distortion is just becoming a stepwise keyframe in the behavior model, which just so if we have a set of distortion maps, that becomes a behavior because every one of them is the changes that you would do at this keyframe.
Yeah. Okay, yeah, I'm
I thought
okay with that. You have a good example there.
I have two examples. I thought this is more for grins as opposed to really educational. Here's a mug with some indentations on it, and I know this mug. This mug is probably like 50 years old or so. It's made by my neighbor, and anyway, you can see here we have a bunch of indentations, but I can remember this because it's a face. And here's another mug made by the same potter many years later, and this one's really distorted, or it's some sort of vessel. But I can't really remember this one because the distortions here are sort of I'd have to really study this carefully to learn all these.
But yeah, I guess you pick
distortions.
up on the feet quite quick, and at least
Maybe the
sort of
feet,
flared
right?
lip.
But the rest of it, you ask me like, oh, Jeff, what's the top of this shape, this top lip look like? I would have no idea and remember it. But if you ask me, what does the face on this guy look like? I have a very good memory of that, And she made this just by putting her fingers in that. I just thought I'd show it to you.
Yeah.
Just for grins.
Yeah, no, that's a good point that we might just learn a new keyframe for the distortion, and if it's too complex, we wouldn't actually learn it.
Right. Or it would take a lot of time to learn it.
Yeah.
You
I guess
if I
I'm
used it,
still like I'm still puzzled, and this might be out of the scope of the problems we're talking about, but like as the potter is making these cups, he knows how to get the cup into the shape he wants. He knows how to apply these local distortions and how they will change the shape of the cup and how those predictions would be made. But yeah, that might be a bit out of the scope.
Yeah, that feels very much
Well-
like the t-shirt, I think. Like how to model clay.
all right. Well, anyway, I think let me see if I can come back and just, for my benefit, just recap what we're saying here.
Yeah, I'm gonna try and write it down too.
We're going to assume multiple morphology models. We're able to map using the compositional hierarchy. We can map objects onto those different morphologies, and they will automatically get to just, if it's if it's like a curved surface, I can just map the logo onto the curved surface. It just happens automatically. Then morphology models can be tied together through behavior models. That is, if the two morphology models were, keyframes or stopping points in a behavior, then that can make a difference. It means I can predict a new morphology model, and I also, I can predict a new morphology model. But we don't path integrate deformations. Right? That was the thing you were trying to solve with the all those displacement vectors. So let's not do that.
So yeah, just coming back to the balloon example, if we have the balloon that's inflating, we would basically just learn a couple of different morphologies of the balloon, like uninflated, slightly inflated, more inflated, fully inflated. And then we would learn a behavior model that tells us how we transitioned through those morphological states. And then if we have certain features on the morphology model, I guess that's the point I'm least clear on, but it sounds like you're suggesting we can potentially solve that completely with the hierarchy solution, the same way we would map the logo onto
Well,
the
without, I'm saying that's a goal, right? That's a goal. I'm not sure I've walked through all the issues, but I think that's a desirable and likely outcome that we can use this mechanism.
Yeah, okay. Yeah, because I'm a little confused because I feel like what we've just described is kind of almost like where we started, and this is, but then the reason we went down this path of having these, like what you suggested, Vivian, and stuff, was to enable this prediction with the balloon and stuff. Like, I don't think we could get it to work with, even if we learned separate keyframes, it didn't enable us to generalize with kind of a known behavior and then mapping like a new logo onto the balloon and stuff like that.
Yeah, I think that's actually, yeah, maybe now it makes sense if I can just briefly walk through the diagram here, because that gets exactly at that issue that you mentioned about the hierarchy solution kind of being very specific to a certain parent-child combination. So I guess if you just glance at the diagram difference between this one and this one, the main difference is that the feedback connection is missing. So basically the compositional solution that we have works already with any kind of object distortions to recognize them, like static ones, not the behavior. I'm talking about static distortions like the logo on the cup being distorted. The only issue I was trying to get around is that this is specific to a parent-child combination and requires us to learn location by location associations in the backward connections to make predictions about the child object, because this is like a unique reference frame to the child and a unique reference frame to the parent. And so in the forward direction, the morphology model is already quite general. We can recognize that kind of morphology of the distorted logo independent of the logo, because we just have the relative orientations in the mini columns at relative locations. So in the forward direction, it is already kind of independent of what the child object ID is, at least to a certain degree. But then in the backward direction, when we make predictions about what to sense on the child object, it is very specific to that child object. So then,
Okay, but the way we got around that was to send back movement commands, right?
that was for in the context of behaviors. Here I'm just talking about static object distortions. Like basically, okay, so this is just showing the general like hierarchy for compositional object solution, where we have orientation of features on the lower level object. So the logo, we have the orientation of features on the logo at certain locations. We have specific features like color at those locations. And then we have the orientation of the logo and the orientation of the cup being calculated together in the thalamus and combined into the orientation of the logo relative to the cup. That activates the mini columns in the parent object and then associates those relative orientations at relative locations. And the logo ID is basically just a feature again here.
But then, you know, didn't we have two backwards projections, right? The purple one you show
Yeah.
here is very specific.
Yeah, and
that says on this particular object, there's this particular feature. But what about, I mean, but the point of sending back the movement commands was that I could predict a new orientation of a generic feature, right? I could say there's a different image on the cup, and it's and I'm going to predict it's going to undergo the same orientation changes.
Okay, I guess I'm not sure I ever thought of sending a movement command in the static case. Like there's no behavior model, there's nothing moving.
It's just purely static case.
Yeah, just the static case. So actually, we have a second backward projection, which is the orientation of the
But okay, let's take out the movement idea. Don't we tell the child object what orientation it should be at any point in time, any location? We have to, right? To make the correct prediction.
Yeah.
In a compositional object, the way we've thought of it, we tell it both the ID on a location basis, but here's the ID and here's the orientation at that location. So I could ignore the ID, but I still would have the orientation, right?
Yeah, so yeah, that's exactly what I wrote here. So it is also general in applying the child orientation. So we are telling it what orientation to expect for a child object, and that's very independent of the child object ID. It's just not independent of the location. The location is in the specific object's reference frame. So I was just wondering, yeah.
Earlier in the beginning of today's meeting, we already brought up a very big problem or an issue that we have to think about, which is, is the reference frame location space, is it a morphology reference frame or is it a specific object reference frame?
Yeah.
And this would work fine if it was a morphology reference frame.
Yeah, and that's why I like that idea so much. Like, or that path, to go down that path a bit further of like thinking of morphology objects as very separate from the features themselves.
Right. In fact, I think it was a week ago or a couple of weeks ago, I kind of blurted out at one point in time, like, we need to just think about all objects being morphology. And that's like the base item. And so in this case, I don't know how to do this yet, right? I got to change our mindset because we've been thinking about specific locations and specific objects, but we need to, how can we get this to work? But if we had specific locations on a morphology object to a specific location on a morphology object, that would work. I think that would that's at least an area to explore and see what happens.
Yeah, and I really like that idea, and I only thought of it at the very end of drawing all of that, like when I wrote that orange. But yeah, I think that's an alternative solution. So basically, this solution is very general, like not specific to parent-child combination in all of these mechanisms, except for the purple connection, which is specific to a reference frame. And the idea I had to circumvent that was to apply movement to the child reference frame, because the movement command is independent of that specific reference frame. But the idea of just using like a general morphology reference frame should also work. So,
but by the way, I think we have to have both. You have to have both the specific and the morphology predictions going on, because a particular mug may only, I know it's going to have the Thousand Brains logo on it. That's what I would expect unless I see something else. So and the same thing here, the feed forward from layer 3 to layer 4 says, oh, well, here's a specific object perhaps on this thing. We want to be able to learn specific associations between specific parents and specific children, but we also want to be able to learn morphology to morphology. We need to do both. So there's still a need for somehow region 2 to tell region 1, you should be, I'm on a specific cup, therefore I'm expecting you to have a specific object in R1. I mean, we don't want to get rid of that purple line altogether. Maybe it doesn't project to the reference frame, right? Maybe the problem is we're tying the two reference frames together, and maybe that's not right. Or if it is, it's two morphology reference frames, but then I need some way of actually saying this is the specific object you should be referring to.
Yeah, I guess we could all use the same reference frame, but then maybe for which cells are activated in a mini column, that could be conditioned on some kind of specific object ID in layer, I don't know, some of the upper layers.
Yeah, I have this requires some, I mean, we don't know how this works yet. I don't know how this works yet, because we don't want to, even for a morphology model, I want the point on the morphology model to be unique to the morphology model. It can't be just a mini column. Mini columns are not unique. It has to be cells. But now, so now I'm going to use the cells to represent a particular point on a morphology model. How do I then create a feature-specific point on a morphology model? It's like, I don't have a mechanism for that yet.
Wouldn't it be enough to have it be a unique location down here, and then the mini columns themselves?
Well, the problem is if we don't want a unique location, we want locations that are unique to the morphology model, right?
Yeah.
So we just said that's if we go all in on morphology. So our cells represent unique points on the morphology model, and the the unique orientations on at different points. We have a unique reference frame for morphology models. Now, how do I add in the specific features on top of that?
Yeah, so I guess what I would kind of propose, just off the top of my head, would be to use the same reference frame for a specific morphology, like all of the objects that have that morphology, like all of the circles.
Right. Okay.
Use the same reference frame down here. They store orientations at locations, and you activate the same location representations. But then, depending on what's kind of the print or pattern or colors or whatever on the circles, let's say we have circular stickers and they have different company logos on them. Depending on which company sticker you have, you might have some kind of specific object ID up here that conditions what cells in the mini column will be activated. But
those cells,
location space.
Those cells, are those cells representing a unique point in the morphology? If they are, then I can't change them to represent, a red thing. You know what I'm saying? It's like they can't do both. They can't be unique to the morphology and unique to the specific object. I can think of ways of solving this problem, but I'm not sure if they're biologically realistic.
Yeah, maybe one thought, I don't know if it's helpful, but just in terms of this kind of unique versus shared morphology model. So it kind of relates to, I guess, something I've been thinking about recently, which is like, if you had, let's say, two subpopulations in L6A, and one of them is the actual reference frame, and so it does path integration and all that kind of stuff. And another one is a bit like L4. It's just kind of like a unique pattern for a particular location, but it can be reused. Maybe it's a bit more like L3 actually, but it can be reused across different instances. If that's what's sending the back projection to the column below, then that could kind of be reused by multiple objects. And so you could have like maybe unique reference frames for like different mugs and stuff, but it means that on all these different mugs, if you're on the handle, they will always activate the kind of common location fingerprint for being on the handle. And then that's what is kind of responsible for sending a projection backwards. So it's kind of it's almost like a form of location pooling across different morphologies for sending the back projection.
Are you suggesting, Niels, that we need a separate set of cells that represent the specific piece, right? Is that?
This is, I guess, more getting towards, enabling it to generalize. But I agree with your earlier comment that like we don't want to give up making specific predictions. So
can I? Let me bump up a level here. All right, the mechanism that the temporal memory is it's really, really interesting, and I'm just stated again. You have a representation in mini columns. It doesn't matter what it is. It's some representation by the activation of mini column. Associated with each mini column, you have a set of cells, and so by then you can have these two representations active at the same time. You can have the mini column representation, and then you can have the individual cellular representation, and they're tied together. Like one's because basically you can think of the mini column as like a cell, and for that cell, I have a number of cells that represent that cell, and I pick one of those. So now I have this level of detail. I haven't thrown away the model. I just have no level of detail.
if we want to have a morphology model, it almost feels like you have to have another level of this. It's like, okay, I have a mini column. Within that mini column are cells, and for each of those cells, I want to have multiple cells that I could activate individually. Therefore, I can have a unique representation of the morphology point, which is a unique representation of, of the grid cells, you know. It's a great mechanism. I just never thought, I haven't thought yet, how could this be extended one more level down? And maybe there's an easy way of doing it. I don't know yet. I mean, the mini columns is an obvious choice. Mini columns, all the cells are representing the same thing. You pick one, done. Now I need like a mini column equivalent for a cell that says, oh, for this cell, I have a set of this other cells that all represent that cell. And I pick one of them and I would be done. That's not actually out of the question. That's not a ridiculous suggestion. I'm not saying there's extra mini columns or something like that, but it's not out of the question that there could be multiple cells that fire together under a morphology model and then become specific under an individual detail model. I can think of some ways that might happen, but it's a little, I don't want to.
I just had another idea. It doesn't completely work all the way through because I'm not sure like how realistic it is to work, because we already kind of said that we can't represent object IDs in mini columns. But I was just thinking that when you even mentioned that earlier when we were talking about feature maps or the t-shirt distorting, the neighborhood relationships are preserved. So if we have like a logo that wraps around a cup or a logo that's on a t-shirt that crumples up, the neighborhood relationships of all the points on the logo are still preserved. So there still seems to be some local structure to the features themselves as well. So basically, when we apply different features to a morphology, like if we just encode the features in the mini column of the object, I see that there might be the problem that we would have to learn the same kind of, I call it feature map, for different morphologies. Like you have to relearn the logo on different morphologies, basically. But an alternative could be that we have some mini columns that represent orientations, and we store orientations at locations, and that those are the morphology models. But then we have other models and other mini columns that represent features like color, like blobs would be that. And those learn kind of relative relationships of features. So it says, all right, in the checkerboard pattern, there are the black ones, and then there are the white one, and black and white, and black and white. And it just learns this kind of neighborhood relationship in a probably pretty simplistic 2D reference frame. And then that's like technically a separate model in a separate reference frame, and you can kind of apply them to each other using hierarchy.
I thought I was following what you're saying, and then I got lost a bit.
Well, basically, in a nutshell, it would be that for learning, like learning what I call feature models now, or learning the features wouldn't happen in the specific cells that are activated in the mini columns, but they would also be mini columns. It would be exactly the same mechanism as we use for orientations at locations. So we would have mini columns representing specific colors, and we learn colors relative to each
that could be. I was thinking a slightly different variation of that, which is, you know, if you look at V1 in the Cortex, you have mini columns represent orientations. And as you go in some directions, the orientation regularly changes. That's how we think about it. But then you go in another direction, the orientations don't change. The mini columns seem to all have the same orientation. And so there's actually multiple mini columns that represent the same orientation. So you could, I'm not advocating for this, but I'm saying, well, the first thing that occurred to me is, well, maybe on the morphology model, all those sideways mini columns are active, but then on a specific, you know, feature location, the subset of them are active, something like that. It's just another level of it. It's another branching out. You have two dimensions of mini column. Another thought that occurred to me that might work, and I haven't thought through it yet, is I wonder if you could use phase of activation to somehow separate out morphology models, some specific models. I haven't worked that out yet, but it's clear to me that phases of cell firings is a big thing in the brain, and we don't really take much of advantage of it. It's in the grid cell theories, but nowhere else are we thinking about it. And I don't know if there's some way you could say, oh, these cells are in phase and then they become out of phase or something like that, to specify which specific object. And you could even go through multiple different hypotheses by going through phase, through time. Anyway, those are just two basic ideas, and none of them strike me as very fun to think about, but I don't like them that much. But it's a little bit like what you were saying, but you were saying something different. You were saying, I think, have mini columns that represent the actual features, like the color blob, which they are there. The color blobs are there. They're not really morphology. Well, they could be if it's the color blobs activate, I think, when there's an edge of color, right? It's like a color transition. So
yeah, I feel like it would be nice if those color blobs and like similar cells was kind of like what we were talking about a couple of weeks ago with like almost like a model-free representation of things, like things where we don't necessarily have a way of describing how to break something down into its subparts, but we just say like, oh yeah, I can see that's architecture, or I can see that's just like glossy white, or that is all these things that we can have. Yeah.
I have the impression that all the retinal ganglion cells, the ones that are color or not color, are all center surround, edge detector type of things. So you would never have just red. A cell would have to be representing a transition from red to something. So they're like edge detectors. Like we're almost out of time here, but I want to leave on a sort of a positive thinking thought. Just again, it feels good to say, oh, let's think everything is about morphology models, and composition is about morphology models, and behaviors are about morphology models, and deformations are about the morphology models. And then we have to ask, okay, how do I make these specific predictions, right? How do I get the specific particular thing?
Yeah, I think it was a good suggestion to kind of think about the egg and the oval and without any features on it, because yeah, I think we can actually solve all of our open issues with behaviors if we just think about morphology, but now we have to think about how to separate the features out from the morphology model, right, and how to bring them back in for the predictions.
Right. The irony is we started the other way around and we had to figure out how to add morphology, and it's like, oh crap, this is so hard. And then now we say, oh, well, let's start with morphology and I have to figure out how to add back features, which maybe won't be so hard.
Maybe it'll be like what you describe is like a 3 streams in a cortical column. It's like one morphology, one feature, and one behavioral. Like remember, like you once had a presentation about behavior, but through 2 kind of parallel streams. But now it'll be 3. We have features.
Yeah, and that's actually what we talked about. Like I think at a retreat 2 years ago, we were like the 3 models: morphology, features, and behavior. And then I guess.
Wow,
and then one got thrown away.
All of my memory is temporary. Nothing's permanent anymore, so I can't remember the conversation at all.
Very cool.
Well, I think it's a liberating idea. Whether it's right or not, I don't know, but it's always fun to have sort of ideas that at first feel liberating. Because it does feel like morphology is the basis of behaviors, and morphology is the basis of deformations, and morphology is the basis of recognition in general, right? Almost everything we recognize, we start with morphology, and then we say, okay, what are how do we add back in these specific features to make unique versions of the morphology?